Now, after this, if we move, let's start with division of integer. Now, it is same, just we know that division is opposite of multiplication, right? In multiply, it is repetitive addition. So, can we say division is repeated subtraction? Yes. When we continuously subtract, it is division. Or we simply say it is inverse of multiplication. Very simple. And we can apply the same thing that we have done in fractions also. Just see, if there is an example, 3 multiplied by 5 is 15. So, we say that 3 times 5 is 15. That means product of these two is 15. Also, we can relate that 15, if it is divided by 3, then the result is 5. And if I divide 15 by 5, the result will be 3. That's true. So, here, one more example is 4 times 3 is 12. We say the statement gives 12 divided by 4 is 3 and 12 divided by 3, you will get 4. Okay. So, same thing can be applicable to all the integers. We can say that for each multiplication statement of whole numbers, there are 2 division statements. This is a very important line which will help you out to do various division of integers. For every multiplication, there are 2 statements for division from one multiplication line, right? So, let us apply it to one of the question here. Like if the statement is 2 multiplied by minus 6 gives you minus 12. So, what will be the division statement for this? It becomes minus 12 is divided by 2 to give you minus 6 and minus 12 is divided by minus 6 to give you 2 as the result, right? But in both the cases, can we say with one more statement if we relate, minus 4 times 5 is minus 20. So, minus 20 divided by minus 4 will give you 5, or minus 20 divided by 5 will give you minus 4. Okay. So, here if this is the question given to you, like minus 12 is divided by 2, you can say the result is minus 6. Similarly, minus 20 divided by 5, the result is minus 4. We observe here that when we divide a negative integer by a positive integer, we divide them as whole number. Let me relate, make it more clear to you. If we simply write here minus 12 divided by 2, it means we can do it like this also, right? And we simply divide 2 and 12. Okay, we cancel them. Like 2 times 1 is 2 and 2 times 6 is 12. So, here we have divided them as whole numbers, very important. And then put a minus sign here before the quotient. Now, this we simply do 12 divided by 2 is 6 and we put a minus sign. Similarly, 20 divided by 5, the result is 4 and we put a minus sign here as it is. Very simple thing. So, for division, it is just, we can say, similar to multiplication but opposite of it. Like in multiplication also, if instead of division here, if it is multiplication, like minus 12 times 2, what do? We simply multiply 12 by 2 and how many negative signs are here? 1. That is an odd number of negative sign. So, we simply put 1 negative sign here. The result here will be minus 24, right? Just check here, same we have done, but now we have done the division. That is, we have done 12 divided by 2, the result is 6 and with the negative sign over here. So, we can relate it very easily, the properties of sign with the sign of multiplication when we have done multiplication of integers also. So, if while doing division, if the integers are of same sign, again the final result is going to be positive. And if they are of opposite sign, the final result is going to be negative. It is just as what we have done for multiplication. So, here we can conclude a divided by minus b, or we can write it as minus a divided by b. The result will be same as minus of a divided by b. But here the condition is that b is not equal to 0. B will not be equal to 0 in this case. Now, the next is property of division of integers. As we have done the property for addition, for subtraction, for multiplication, we have some properties for division also. Very relatable to the previous properties. the closure property. Now you can tell me directly that if a and b are integers, then it is not necessary that a divided by b is also an integer. For example, if I take 2 as an integer, or 3 as an integer, or 21 as an integer and 4 is another integer, if I divide 21 by 4, I know the result 29 by 4 is not an integer. But if I divide 24 by 6, the result 4 is an integer in this case. That means we can say it may be an integer or it may not be an integer. So that means if there are two integers in that bag of integers, the division of the two integers might not be present in the bag. So we can say the closure property does not hold true for division of integer. So if we conclude all the properties, we say it holds true for addition, it holds true for multiplication, but it does not hold true for subtraction or for division of integers. Similarly, we can see for the next property, that is commutative property. It says again, if a and b are two integers, then a divided by b will not be equal to b divided by a. It is not necessary. For example, I know 9 divided by 3 is not equal to 3 divided by 9. You can relate it like 9 divided by 3 means basically you say 9 divided by 3 here is 9 upon 3 and the result is 3. But if I divide 3 by 9, this is nothing but this is 3 divided by 9. Okay, I am dividing 3 by 9. So 3 times 1, 3 times 3. The result is 1 upon 3. But when I divided 9 by 3, the result was 3. And clearly 3 and 1 upon 3 are not equal to each other. So we can conclude from this that a divided by b is not equal to b divided by a. So commutative property also does not hold true for division of integers. You can also see 6 divided by 2 is not equal to 2 divided by 6 because this is 3 and this will give you 1 upon 3. So these are two different answers for the question. So we can say division is, it's not, commutative property is not true for division of integers. Now what about associative property? If there are 3 integers, then also it will not hold true, because if it is not true for 2, how can it be true for 3 integers? So it does not hold true for associative property is not true for the integers in their division. Like 16 divided by 4 divided by 2 is not equal to, like you cannot rearrange also, you cannot reframe it also, you cannot make groups for division as well. You can see this gives you 4 as a result and 4 divided by 2 you get 2. But here if I go, this is 1 upon 4 and divided by 2, again I'll not get the result as 2. Okay, this we'll learn in the next chapter, fraction also, how to do division of integers. But to make it very clear, in short, we cannot use associative property here for division of integer. The next property that we'll take is property of 1. So what is the property of 1? That if any number is given to you and if you divide that number by 1, what should be the result? In this case, the result will be that number itself. For example, if you divide 4 by 1, the result you will get is 4. If you divide 3 by 1, the result will be 3. If you divide 100 by 1, the result will be 100. That means if you divide a by 1, the result will be a only in this case. For example, you can see 4 divided by 1 is 4. Even if you apply to negative numbers like minus 7 divided by 1, the result will be negative 7 in this case. So this property of 1 is also clear to you. Let us now see the property of 0. What it says? If I divide any number by 0 or 0 divided by any number, they are two different things again, because we cannot apply the commutative property here. So 0 when divided by any number a, you will get the result as 0. But if you divide a by 0, this is not defined. Let me be more particular about this division. Suppose if I am having 0 chocolates with me and I want to give it to 5 students. So, how many chocolates each student will get there? I am not having any chocolate, I have 0 chocolate. But I have to give to 5. I can give them 0, 0, 0. That means it is, the final result what they will get is 0 chocolate, right? And now, just opposite of it. If I am having 5 chocolates with me, that means if I am having A chocolates with me, and I have to divide it among 0 friends or 0 students, there is no one to whom to distribute, but I have to distribute those 5 chocolates. So is it possible for me to give any number of chocolates to anybody? No, because there is nobody to whom I have to share the chocolates. That means this is not possible at all. So A divided by 0 is not possible or not defined, but 0 divided by A is possible, and the result will be 0 in this case. So here this is the property of 0. So here we can see if 0 divided by 7 is 0, but 7 divided by 0 is not defined, not possible. Similarly, 0 divided by 10, you will get the result as 0, but 10 divided by 0 is not defined. So I hope the property of 0, the property of 1, different properties for integers, that is the closure property, commutative property, associative and distributive property for integers under their addition, subtraction, multiplication. I hope all these properties are clear to you all. All the best. Thank you so much.